Hello and good morning. Let's do a quick check-in for Module 3. So this is week 4, and some of these weeks are going to be staggered where we have more than one module, or excuse me, more than 1 week per module. This will be Module 3, week 4. Jumping in, you'll see, I need to change that setting. Let's go ahead and turn edit off. Here's Module 3, our descriptive stats for 4 and 5. Jumping in here, here are your overview for what we'll cover. And you'll see that we are talking about central tendency. And central tendency is very important to statistics. Most, gosh, when we're determining significance at the end of the day, whether and we're analyzing, our data for our assessments, for our psychometric assessments, we're oftentimes dealing with measures of central tendency as the basis, as the platform for understanding what's going on in these instruments. So it's important that we get these fundamental concepts. You're welcome to look over what's in store for week 4 and for week 5. Let's go ahead and jump straight into the lecture and the notes. And I'm going to flip this around a bit, and I'm going to, excuse me, see if I can make this a little bigger. Nope, that makes it smaller. I'm going to actually cover, before I get into these diagrams, before I get into the tables and charts and illustrations of central tendency, I think we need to understand central tendency itself before we get into those things. So here's the first part of our lecture, are really 3 terms that deal with central tendency: the mean, median, and mode. Hopefully this is review for most of you. And the mean is simply referring to the average. So if you take a list of, say, 10 numbers, add them up, get a total, and then divide that by the number of numbers, you'll get the average. So in this case, you have 25, 30, 32, 35, 38, 40, 42, 45, 48, 50. If you were to take your calculator, this is very simple. Y'all can do this. It's simple addition and division. So make sure I can see all my numbers. All right, here we go. So we're taking 25 plus 30 plus 32 plus 35 plus 38 plus 40 plus 42 plus 45 plus 48 plus 50. Come out with a total of 385. And then there are 10 scores there. If you count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You divide that by 10, and you come up with 38.5. That is the mean, that is the average of all of these anxiety scores for 10 students, 38.5. And so that's how you just determine mean. It's pretty simple. Hopefully you believe it's simple. And so we try to find the mean. Finding the average score is the basis for most of what we're going to do with statistics. Now, we're not going to compute this because we have sophisticated computer programs that do all that math for us. When I first took statistics, and I think even when I took statistics again, I was actually using something like this here. So this is a TI-81, or is it 83? TI-83 plus. I think I used the TI-81 too. It was required for my statistics class. And so you can see all the little functions that go along there. And the I guess you'd have an alt button and a control button and all that stuff on this old statistics and graphics calculator. So you could actually graph some things on that screen there. So thankfully, you all don't have to purchase one of these and compute all of these formulas by hand. Before IBM SPSS, that's what researchers had to do, and statistics were, I would argue, much more daunting. One of the cool things about all this sophisticated, I guess you could say that's kind of an artificial intelligence in itself, in that our We have such a robust statistics programs now that they can compute these multi-step, mathematical problems and come out with without human error because it's been programmed in the computer the right way. So, that's a big, time saver for us. Hopefully, you believe that to be an advantage too. The median is the middlemost value. And so the middle value is it's the number that falls directly in the middle of and it should be a whole number. If it's not a whole number, you're not coming up with the median. So the median should be, well, at least in this case, we'll talk about the median a little bit more here in just a moment. But the median is the middle value when a data set is arranged in ascending or descending order. So in this case, you find the middle values. So you count in 1, 2, 3, 4, 5. And we've got 10 values. So we've actually got 2 values in the middle. We've got 38 and 40. Those are the values that and the scores that are in the very middle of this distribution. And so in this case, you'd actually add 38 plus 40 and divide that by 2 for a total of 39. So the median in this case is 39. Now, let's say that we take out a score. Let's take out 50, and we have an odd number of scores. So now we have 25, 30, 32, 35, 38, 40, 42, 45, 48. So now the middlemost score, if you don't have an even number, if we have an odd number of scores, we have 9 scores. Now you can see that 38 becomes the median. And we don't have to do any extra math because we have an odd number of scores. That's the key when you're figuring the median, is that you have if you have an even number of scores, you have to take the 2 middlemost scores and divide them by 2. If you have an odd number of scores, you just find what score falls in the direct middle. So it's a little different than mean. It's called median. And so you can, for the use in psychological assessment, you can, it's a good alternative when the data is skewed. If it has outliers, you can determine a median. The mode is the score that is, it's the score that occurs the most often. So in this case, we don't have a mode with our original data set, the 25, 30, 30, because these are all different numbers. You'd have to have a number repeat to actually have a mode. And so I've given you another data set right here with 25, 25, 25, 35, 38, 40, 42, 45, 50, 50. What is the mode? Wait a minute, we've got 2 numbers that repeat. Well, in this case, it's 25 because you have 3. And you can see that the mode is not really in the middle, right? It's really just what score occurs the most. And so if you actually had 3 50s, you'd have a bimodal distribution, because then you'd have 3 50s and 3 25s, and then your distribution shape is looking like a U. And that can be problematic when you're talking about how distributions are shaped. So when we're dealing with this, when we're dealing with measures of central tendency, we then have things that can help us see them in really quick, like we don't have to have them all laid out. Like it's tough to see what a distribution looks like if you have them all just the raw scores laid out in front of you like this. So what we try to do is we try to create graphs and plots that help us see what the data looks like. And so we're going to deal a lot with histograms. Histograms give you basically a bar graph where data is clustered and shows you where most scores lie. So if you were looking at a histogram, our textbook gives us examples. Let me hit pause and come back and show you these, because I don't want to take too much time up in the video.